Hello, everyone. I take it you can hear me. I sound quite loud. All right, I'm Christian Wade. I'm a Senior Program Manager for Analysis Services. How are we all doing today? You know what's coming. How are we all doing today? All right, let's get the energy levels up a bit. All right, so I'm going to be talking about Azure Analysis Services. Do you mind putting your hand up if you've ever developed an analysis services model in your life? Yes, I feel at home, really. That is great news. Okay, so I'm going to jump straight into a demo to show you what it looks like from the end user's perspective. Who was here for Josh Kaplan's session yesterday? Okay, a handful of you. So he showed the New York taxi demo. I'm going to go into a bit more detail in terms of how we built that model and the automation opportunities and scalability, application lifecycle management. And I'm going to focus also on how to bridge the gap between self-service and corporate BI. How do we as IT professionals harvest insights from analysts and incorporate them into existing corporate BI models? Okay? Sound good? Okay, I'll take that as a resounding yes. All right, and by the way, feel free to ask questions during the presentation. I will not be offended, all right? Okay. So this is the New York taxi model, and this is a big model. It has, this is about 9 terabytes of data in its raw, uncompressed form in CSV files. It's on a whopping great server with somewhere in the region of 50 cores and 400 gigabytes of memory, all right? And this represents all of the New York taxi rides across a 10-year period. It's been exploded a little bit to show off the scalability of Azure Analysis Services, okay? So this table here that you can see with all these columns represents the New York taxi trips. And this measure here is embedded in the analysis services model because we're connected with a live connection. So Azure Analysis Services is taking care of the modeling and data storage for us. And this measure is a count rows of the table. So let's just casually drag this over onto the canvas. No big deal. Bang, 10 billion rows. Right, let me just make this a card. 10 billion rows, instant response times, right? That's how we roll, instant gratification, right? We can, let's say, we can create measures in here now as well. So that measure is embedded in the model for reusability throughout an enterprise organization, but that doesn't mean that a consumer of the model in Power BI can't create a measure to support the train of thought at the current time. So I'm going to go ahead and create a new measure. We'll call this revenue by trip equals divide revenue by trip count. And just like that, we have a DAX measure. Who said DAX was difficult? Seems easy, all right? And I now drag over the zip code. Naturally, we want to see which are the most profitable zip codes. We instantly get response times over a 10 billion row data set, all right? This is what I like to call clicky-clicky, draggy-droppy data analysis, all right? I just interactively navigate through the data, and it gives me instant response times. Naturally, we want to see this on a map. This is Power BI. We have the rich visualization stack at our disposal. And there we have all of the pickup locations in New York. And with the cross-filtering in Power BI, we can zoom in, and we can see that the pickup locations are actually, many of them are on the freeway. So people are, you can see the story behind the data. People are running out on the freeway to catch a taxi because they're kind of in a rush. And I'll just point out here that we've gone from a 10 billion row aggregated cell value all the way down to an individual pickup location just in a few seconds, right? and the other one is LaGuardia. Okay, so that's what it looks like to the consumer, right? This is the metadata of the semantic model that is then reused throughout an enterprise organization. This is what the users see. Let's now switch over to the IT professionals standpoint and start talking about Azure Analysis Services. And actually, just before I do this, I need to do one little thing. Okay, I'll come back to that. Okay, so as you saw, Azure Analysis Services allows us to build rich semantic models that encapsulate large, integrated, managed data sets. These data sets are typically owned and managed by IT. This then unlocks the value of that data in corporations and large organizations so that it defines the user interface that the users see when accessing that data and just unlocks the value of that data. As you saw, we can interact with the data at the speed of thought, clicky, draggy, droppy data analysis over massive data sets, all right? And it's proven technology. Analysis Services has been around for a long time. It's a product with a long and distinguished history, which is now at the dawn of a new era, as it's a fully managed platform as a service in Azure, which implies cloud hyperscale, the ability to scale up and down in an automated fashion, which saves a lot of money for customers. It implies high availability as part of the SLA at 99.9%. High availability. It implies the ability to spin up servers in seconds rather than days. And it just gives you as part of your IT organization the agility to respond to business needs more quickly, right? And it allows organizations to focus on building quality business intelligence models rather than managing a bunch of servers and infrastructure, okay? Any questions? Don't be shy. No? Okay. So this is a high-level overview of the architecture. I'm going to breeze through this because I want to spend most of the time in demos. So we have client tools that submit queries in DAX or MDX. So the Power BI service, for example, will submit DAX queries to Azure Analysis Services. And Azure Analysis Services can be co-located in the same data center if you find out what is the primary region for your Power BI tenant, and that makes it much more efficient for Power BI to access Azure Analysis Services. If you imagine SQL Server Analysis Services on premises, it would have to be below the line delineating on-prem and the cloud. So the Power BI service would have to go through the gateway just to access SQL Server Analysis Services, okay? Any questions about the architecture? Nope. All right. So I'm now going to switch over to the Azure portal. We're going to do some automation in here. So let's start off in the Analysis Services section. And I'm going to click Add to get to, yes? I knew that, Brett. Thank you very much. I was just testing. Thank you very much. Thank you. Appreciate it. Okay, so here I'm in the Create Server blade, okay? And if we go to the location section, you can see that we are in many data centers all over the world. We have pretty good coverage. And if I come to the pricing tier, you can see that we support servers ranging from the entry-level developer SKU with 3 gigabytes of cache, all the way up to the S9 with a whopping great 400 gigabytes of cache and 640 query processing units. How many cores is that? A lot. We abstract the number of cores so that it allows us to change it if we need to. So instead of creating a server here in the Azure portal, what I'm going to do instead is I'm going to do it from Cloud Shell, since this was just announced at Scott Guthrie's keynote. I thought we might as well give it a whirl. So first thing we want to do is instantiate a new server. And I just want to kick this off. So Let's see how long it takes to instantiate. And as you can see, I instantiated it as an S0, right? An S0 has 10 gigabytes of cache. So whilst this is running, just think about for a moment, what was the process to stand up a server on-prem? You would probably do some hardware sizing, you'd submit a request to your infrastructure organization probably, you'd wait a couple of days if you're lucky, you'd get a server that was not really optimized for analysis services in terms of hardware, in terms of NUMA awareness, clock speed, etc. And that's done already, so that took, let's say, 40 seconds. And you would then install analysis services, install drivers, configure the memory allocator if you even knew what that is, right? And you'd be looking at a turnaround of a few days to actually start deploying models onto that server. So as you can see here, it takes 40 seconds, right, which gives you a much better level of agility to respond to business needs, right, to unforeseen usage trends, etc. And not to mention the fact that you don't need to manage the server, you don't need to patch it, etc. You don't need a whole Windows Server admin team to look after these servers. Okay, so the server is ready. So what I want to do now is I want to deploy a model to it. Now, I'm going to run this command, and it's going to fail. And it's intentional because I want to show you what you need to do to be able to do this yourself. So it's failed with an authentication failure. So this is the invoke ASCMD commandlet, which is one of the very popular commandlets that we get with SQL Server Analysis Services, right? So Azure Analysis Services has inherited all of the PowerShell commandlets. It has inherited all of the API surface area. It's inherited all of the management tools and community tools, etc. Now, this particular commandlet is performing a database level operation, whereas the one where we instantiated the server, this was an Azure resource management operation, right? Cloud Shell automatically logged us into Azure. So we did not need to run login Azure RM account. However, creating a database is not an Azure resource management operation. It's a database level operation. It has a different audience. So we need to provide credentials for the purpose of managing SQL Server or managing Azure Analysis Services models. Okay, so let's go ahead and do that. It's my credential. Okay, and now I'm running, instead of login Azure RM account, which is to log into Azure for resource management operations, instead I'm using login Azure AS account, which looks similar, but this is for database level operations, okay? So that now I should be able to run the SQL Server Analysis Services commandlets. Okay, makes sense? So I will now rerun the command to create the database. And whilst this is running, you can see that this is running a, let's just rerun that. This Cloud Share is in preview. So this is running an NXMLA file that actually contains a tabular model scripting language script, which looks like this. This is a create database script for Azure Analysis Services. It also works on SQL Server Analysis Services, okay? This is actually the taxi model, right? We're creating one with no data in it right now. This has a compatibility level of the 1400 compatibility level, which is available in SQL Server Analysis Services 2017, which will GA on October 2nd, next Monday, all right? So that's the file. Now, I uploaded the file to my Cloud Share, which is why I was able to access it from the invoke ASCMD commandlet, and so that's run. So now we've provisioned the server, we've created a database on it, but it hasn't got any data in it yet. So now we want to perform a processing operation. We call processing when we want to refresh data in the model. So let's go ahead and run a processing command. So this is another commandlet from the SQL Server Analysis Services commandlets. And you can access, so logging into CloudShare, it already installed the SQL Server module, but this is available from the SQL Server module if you need it. Okay, so that's done. And I only refreshed one table. I refreshed the date table only in the model. That's obviously a big model. It would take a while to refresh all of the data, right? And this is one of the features of Analysis Services is you have very fine-grained control over what data you refresh. You can refresh individual tables. You can refresh individual partitions, either sequentially or in parallel. You have lots of control and fine-grained options there. So this model is now there. So what I'm going to do now is I'm going to run a quick query on it. And I'm back here in Management Studio, which, as I mentioned, has full compatibility with Azure Analysis Services. All of the client tools for SQL Server Analysis Services just magically work on Azure Analysis Services. You know, it has the same API surface area, the same modeling surface area. The lift and shift story from SQL Server Analysis Services to Azure Analysis Services is, you know, pretty seamless. And I'm not just saying that because I'm a PM for Analysis Services. It really is. So I'm going to go ahead and create a new DAX query. And DAX queries are new in Management Studio. We no longer have to write DAX in an MDX query window, which I'm sure Marco over there, this is probably the inspiration for Marco building DAX, or Marco and Darren Gosbell building DAX Studio. All right, so we're almost connected here. And you have to forgive the server. It was only born a few seconds ago, right? So it's building up some caches. OK, so I'm going to now say evaluate. And then here I get full IntelliSense, et cetera. But in this case, I'm just going to evaluate date, which is the equivalent of a select star from date, just to show you that there's data in there. OK? So back over here. So we've got the model. If you remember, I instantiated the server, or provisioned the server as an S0. So let's actually find the server in here. And just give it a second. There it is. So as you can see, it's an S0. And if you remember, an S0 has 10 gigabytes of cache. Let's say I want to upscale this for whatever reason. We'll talk about the reasons in just a second. I want to upscale this to maybe an S1 with 25 gigabytes of cache. So let's go ahead and enter the command for that. And as you can see, I'm setting this to an S1. Now, just think about what this means, right? This means that you can scale down your servers when not in peak usage based on your SLA. You can scale up your servers just to be able to load large volumes of data when you need extra horsepower and extra memory. And as soon as you're done loading the data, you can scale it back down again. I've seen a lot of on-prem servers where during the course of the day, only a very small percentage of the memory is being used, and it needs that much memory just to be able to load the data, right? So this gives you a lot more options. You only actually pay for what you use. Right? You scale it up, you load some extra data, and that might take 20 minutes, and then you scale it back down again in an automated fashion. Right? So this implies significant cost savings and significant efficiencies for you as IT professionals or for your organizations. OK, so we've now scaled up the server. It's refreshed it here. It's now an S1. OK, and since we're done with it, let's just go ahead and delete the server, since I like tidying up after myself. And my wife thinks so too. All right, so let's go ahead and remove that server. Now, as it's being removed, just think about what just happened there. I only paid for that server for the 5 minutes that it was in existence, right? So this opens up a whole new world of opportunities. I can, for example, spin up a server as part of an automated build, as part of a CI/CD process. I can then deploy a model to it, refresh some data, run some tests, and then just delete the server. And I only pay for the server for the 5 minutes or so that takes, right? So there are lots of opportunities here that we did not have. And if we come back in here, and we should, I'm pretty, just to show you that it's gone. And there it is, the server's gone. Okay, so just to finish off this automation piece, it's great that we're running these PowerShell commandlets here in Cloud Shell. Lots of fun. And as Corey Sanders said, you can run this on your iPhone. And I happen to be an Android guy, so I immediately looked up whether I could also execute commandlets from an Android device, and I'm happy to announce another big announcement for the Ignite 2017 conference. You can run PowerShell commandlets from an Android device in CloudShare. Brilliant. And OK, so this is great, but the reality is, if I'm automating this, I'm not going to be running the commandlets by hand, right? I want to schedule the execution of this. Right? So we can do that here in using Azure Automation. Another point is that I would not want to run this under my current credentials. Right? If you remember, I logged in using my own credentials. I would want this using an application service principal. And an application service principal is the Azure equivalent of an on-prem system account. Okay, so really quickly to show you that, if I click on Azure Active Directory, here in Application Registrations, and so here's one I created earlier. So it gets an application ID, which you use in place of the username, or in place of the Azure Active Directory UPN/email address. And it also gets one or more keys, which you use in place of the password. Okay? So with that, I can now come to Azure Automation. And I have an automation account already set up. And here I can set up I can securely store the service principal as a credential, right, including the key, and they can be certificate-based as well. And then with that set up, I can come to the runbooks. And so if I show you this one, and obviously they can subscribe to schedules. And here you can see that I'm using the service principal credential that is stored in the credential store for Azure Automation. I'm then using login Azure AS account instead of login Azure RM account because I want to perform a database level operation, which is to refresh the date table on an instance of that taxi model. OK? So that's it for the PowerShell automation in the Azure portal. Any questions about that? Go ahead, sir. Yeah, so it will take me a minute or so to get the PowerShell gallery pages for those modules. But the modules are the SQL Server module for the database level operations and Azure Analysis Services for the other ones in terms of server provisioning and the other for scale up and down and things like that. And I will provide some resources at the end that I think would help as well. OK, any other questions? No? Another one? Go ahead. Yes. Yes, yes, absolutely. But then the difference here is that it's yes, thank you, thank you. The question was that using Azure Automation, it was the equivalent of scheduling it using a job server on premises like SQL Server Agent or something like that, correct? Yeah, so that's exactly what it is. And the advantage here is that you do not need to spin up a virtual machine and maintain it, and you maintain an end-to-end platform as a service architecture. Okay? Any other questions? Thanks. Okay, let's move back to the slides, and then I'll get through a couple more slides, and then we'll have one big demo. So to summarize what we just saw, we performed a bunch of operations, server provisioning, create a model, etc. Some of these operations you could already do on premises using the SQL Server Analysis Services commandlets, which are available from the SQL Server module. Some of them you could not do, like spinning up a server in seconds, scaling up and down a server, deleting a server, and the one I didn't show over here is pause and resume. So if you pause the service, which again you can obviously do from PowerShell, you do not pay a penny whilst the server is paused. You don't even pay for storage, okay? And we looked at application service principals, which are the Azure equivalent of service accounts. We looked at Azure Automation, which allows us to schedule execution of PowerShell without requiring a virtual machine. We looked at Login Azure RM account versus Login Azure AS account for Azure Resource Management operations versus database level operations. And we also saw that SQL Server Management Studio connects to Azure Analysis Services, as does SQL Profiler, as does the Deployment Wizard, as does a bunch of community tools like DAX Studio and Tabular Editor and BISM Normalizer, right? So Azure Analysis Services is lucky in that it has inherited a lot of intellectual property and a thriving community from SQL Server Analysis Services. And given that the modeling and API surface area is symmetric, it means that not only does that enable lift and shift very easily, but it means that existing applications and the existing community will adopt Azure Analysis Services easily. Okay, I did not show scale out, which will be on the production clusters in a couple of weeks. So scale out was very challenging to do on premises. It's a simple slider bar in the Azure portal with Azure Analysis Services, and this will allow you to support hundreds or thousands of concurrent users. Again, you can automate all of this with PowerShell. So you can say, at peak time, I want 5 read-only replicas, and when not in peak time, I want to scale down to 1, and you only pay for the 1. And another reason to perform scale out on premises traditionally was for high availability. Well, as I mentioned, we have 99.9% high availability as part of the service, even without scale out. Okay? And I did not show backup restore. Backup restore is something you can do from PowerShell as well using the SQL Server Analysis Services commandlets. And the only difference is you need to associate an Azure Blob storage account with the server so that it can read and write the backup files. Okay? Any questions? You sure? Okay. Sure. Go ahead. Okay, so the place we normally put C# code for automation purposes is Azure Functions. And I'm actually going to show that in a minute, so bear with me on that. And I'll just quickly clarify that for these types of operations, like what you saw, it's probably quicker and easier to just set it up in PowerShell. But if you want the fine-grained control of really granular, parallelized, incremental partition management for massive models, you may need to use the tabular object model from C#, which you can reference from Azure Functions. And I'm actually going to show that in a minute. Okay? Any other questions? No? Okay. So this is the Microsoft BI platform. And I think it's fair to say that Microsoft is really the only vendor that can claim a strong presence in self-service business intelligence, in terms of self-service business intelligence modeling in Power BI Desktop, as well as corporate business intelligence, which is owned and managed by IT for large, scalable, managed models with Azure Analysis Services, all right? And we have, I'm going to actually demo import from Power BI Desktop to Analysis Services. So we have a scale-up story to Analysis Services, which helps bridge the gap between the two camps. And this standardizes skill sets in organizations and streamlines these workflows and avoids reinventing the wheel every time you want to harvest an insight from an analyst who created a model in Power BI Desktop. And I'm actually going to demo that, okay? And as I mentioned earlier, SQL Server Analysis Services has a symmetric modeling and API surface area, which enables lift and shift very seamlessly. Okay? Any questions about this? Okay. So just before I jump into the final demo, which will take up basically the remaining 45 minutes or so, what we're going to do in the demo is harvest a self-service insight, a self-service model, and integrate it into an existing corporate BI model. So let's just take a moment to talk about self-service and corporate BI, right? So self-service BI is normally characterized by having a large number of small models. It doesn't mean that they have to be small. You know, we now have Power BI Premium, which allows 10 gigabyte models, but just in terms of the strategic objective to empower the analyst to discover new insights quickly and easily in an unconstrained way without a dependency on IT, just given that objective, statistically, we're going to end up with a large number of small models, normally, okay? Whereas corporate BI, on the other hand, and Analysis Services is, you know, a corporate BI, is the sweet spot for Analysis Services is corporate BI. Corporate BI, on the other hand, is normally characterized by having a small number of large models because we have a different strategic objective. And the primary objective there is for reusability, for standardization of data definitions and information architecture definitions to promote data governance and data quality and consistent decisions in an enterprise organization. So given that we want to maximize reusability, we're naturally going to end up with a smaller number of models, but they're going to be a lot bigger. Okay? Makes sense? And the key challenge now, now that self-service and corporate BI have both matured, I think the key challenge is how do they work together in harmony, right? How does the business and IT work together well? So I have a Gartner white paper that recognizes that centralized teams can identify the most successful work being done at a local level and provides a platform to share and promote this work globally. So I'll be the first to admit that this is more of an organizational problem than a technology problem. However, it just so happens there's a company called Microsoft that has an end-to-end modern business intelligence platform that supports both self-service and corporate BI, and the products actually share the same engine, right, which enables this workflow, it streamlines this workflow for you to harvest self-service insights for corporate BI. And as far as I'm aware, no other vendor can really claim that, okay? So this is going to be the demo architecture. So we have the taxi model with the 10 billion rows, right, in Azure Analysis Services. And it's pulling data from a SQL data warehouse. As I said, this is about 9 terabytes of data in its raw, uncompressed form. And as the gentleman over here mentioned, I'm actually using Azure Functions to perform processing because I want that really fine-grained, granular control for parallelized partition management. And I'm doing that from Azure Functions instead of a virtual machine to maintain this end-to-end platform as a service architecture, similarly to the other question about scheduling PowerShell from Azure Automation instead of from SQL Agents, right? So I'm maintaining this end-to-end platform as a service architecture. And then a self-service analyst has created a model that happens to have some weather data in, right? The business would love to see the weather data correlated with the taxi rides, right? Which makes sense. So we want to take this Power BI desktop file that has the weather data in it, and this weather data is coming from Azure Blob Storage, okay? So we're going to take this Power BI desktop file, and we're going to integrate it into the existing taxi model. and that will thereby create a new data source to the Azure Blob Storage. Make sense? And again, the reason we're integrating it into the existing model is because we want to have a small number of large models. We want to see weather and taxi rides side by side in the same model for maximum reusability in an enterprise organization. Okay? All right. So let's switch over to the virtual machine. So I'm here in Management Studio, and this is the taxi model server. First thing I want to show is the partitions on the trip table. This is that table with the 10 billion rows. So it's 10 years of data, and it's partitioned by month. So we have 120 partitions. And interestingly, if I look at the query statement, it's actually not a query, it's an M expression. Right? So if you remember, this is a 1400 compatibility level model, which is coming out in SQL Server Analysis Services 2017 and is obviously already in Azure Analysis Services. And one of the new features in the 1400 compatibility level is Power Query or M integration, right? Which gives us this extra abstraction layer on top of the data sources. So if I was migrating from Teradata to SQL Data Warehouse, which happens quite a lot. Anyway, if I was migrating from Teradata to SQL Data Warehouse, I, in theory, wouldn't need to change this M expression, okay? And let's see. Now, in order to create these partitions, I'm obviously not going to create all of them by hand, right? I want a process to automate the creation of them. Not just the creation, but also the deletion. So this will be managed as a rolling window. Obviously, I'm not going to refresh all of the data in that model every day. The laws of physics would prevent that, right? So I need, just like a data warehouse, I need to manage a parallelized incremental load for it to work quickly. Right? So therefore, I need to, when I start a new month, I'm going to delete a partition from 10 years ago, and I'm going to refresh maybe the last two partitions, which are the only months where data can change. Make sense? I'm not going to refresh all the 10 billion rows. Okay, so in order to do that, as a gentleman suggested, we're doing it from Azure Functions. So this Azure function has a reference to the tablet object model DLLs, which then allow it to perform that fine-grained partition management. And there is a white paper that I will provide a link to at the end that is what that code sample is doing. And we're actually working on making this easier, more kind of policy-driven. But I'll give you a link to this later. So this is what gives you that fine-grained partition management for these massive models. Okay? Now, this is the self-service model. There's not much in it. I could show you the tables, but we've got this weather data, and this is the model that we want to harvest so that we can see the weather data side by side with the taxi rides, right? So we now have import from Power BI Desktop. So I'm going to come here to this server, and I will open the new web designer. And hopefully my authentication is still there. There it is. Any questions? Okay. So this is the server. These are the models on the server. I'm going to create a new model, and I'll call it weather. And I'll import from a Power BI Desktop file. And so this will take the Power BI Desktop model that is an embedded model, and it will upscale it to Azure Analysis Services. And in some cases, this is all I would need to do. I could then connect to that model using Power BI Desktop with a live connection, right, like I did in the demo at the beginning, where Azure Analysis Services is taking care of the modeling and the data storage. But in this case, I want to go a little bit further. And since I'm here in the web designer, I'll just show you that we can edit these models. We get a significant amount of modeling capability here. So let's see, we can set up new relationships. Just ignore these date tables for a minute. I'll talk about those in a minute. So you can create new relationships. You can create new measures and edit measures. Just give it a second to refresh that. So you get a significant amount of modeling capability in here. You can select multiple measures and set properties in one go, okay? And you also have access to the script view, which gives you a JSON representation, which gives you access to set all of the properties supported by the engine, not just the ones that the web designer allows you to set visually, all right? Okay, so this model is up in Azure Analysis Services. I'm now going to switch over to SQL Server Data Tools, which is the traditional modeling environment for SQL Server Analysis Services and Azure Analysis Services. All right. When I create my models in here, it is disconnected from the server, right? And then I deploy it to either a SQL Server Analysis Services server or an Azure Analysis Services server. The modeling experience is exactly the same. It barely knows where I'm going to deploy the model to, which is just a testimony to the fact that the modeling surface area is symmetric across the products. Okay? So I want to bring, this is the taxi model. This is what it looks like in SQL Server Data Tools. And I want to bring that weather data set and integrate it into this data set. How am I going to do that? There is a tool. So actually, I'm going to come into extensions and updates. And I'm going to go online and search for SSDT. So I'm in Visual Studio 2017, which gives us, source control integration and automated build integration. Here I have the Analysis Services extension for SSDT, which is what allows us to create these models. You can get that extension by installing SSDT, or if you only want this extension, you can install it from here, and it's quicker, and also to get new updates for it, it's quicker to do it this way. And I also have another extension here called BISM Normalizer. This is a schema compare tool for analysis services. Right? This is an open source tool that is on the Microsoft Analysis Services Git repo, and Microsoft, maintain this tool. So it's schema compare for analysis services tabular models. Schema compare for relational databases is a mature area, right? Who here has ever used schema compare tools for relational databases? Be honest. Thanks. I'm going to demo it in just a moment. So you have schema compare in SSDT. You have Redgate SQL compare, which is integrated into Visual Studio 2017 partially now as well. And so I'm going to say new tabular model comparison. And my source will be the server that we just uploaded the weather model to. My target in this case will just be the project. So it needs to close the bin file. And it will now do a comparison across the two models. And it will list all the differences. All right, so in this situation where we are harvesting either a self-service analyst model or maybe a prototype, and we want to integrate it into an existing mature model, there will normally be lots of objects in the target model that we don't want to mess with, right? It's a mature corporate model. We don't want to mess with all of these items that have a delete action item. We don't want to delete them, right? So rather than selecting skip to delete them all individually, I will instead say skip all objects missing in source. All of the deletes get skipped in one go. I can now say hide skip objects, and we can focus on what we're going to create in the target model. So these are the objects from that Power BI desktop file that we uploaded to Azure Analysis Services. Clear? Okay, so here we have the Azure Blob data source. That particular model was also pulling data from a SQL data source. It was pulling some freight data from a SQL data source that for whatever reason we're not interested in. So this would be quite common. We just want to harvest nuggets from self-service BI. So we can skip that data source. And then these are those hidden date tables that Power BI Desktop creates, and you can disable Power BI Desktop creating them. The reason Power BI Desktop creates them is so that, and they're hidden from the user and even from the modeler. So these tables allow a user to drag, in Power BI Desktop and the Power BI Service, a user can drag a date column onto a visual, and it presents itself as a date hierarchy instead of a regular date column, right? Now, since the taxi model is on top of SQL Data Warehouse, and typically in a data warehouse, we would already have a date dimension table. We don't need these tables with the GUIDs. So we'll go ahead and skip all three of those. And we can now validate selection. And so it will now tell us what it's going to do and what it's not going to do. So it's saying it is unable to create the freight M expression because it depends on that SQL data source that we chose to skip. And similarly, it cannot create the freight table because it depends on the freight M expression. And similarly, it cannot create a couple of relationships which depend on those date tables with the GUIDs, right? So this dependency analysis is what makes any schema compare tool usable, right? This is what allows us to, for example, say, generate script. And this creates a tabular model scripting language script, like the one that we saw earlier, that we ran from PowerShell. This is just a script with all of the differences in, and we can be confident that we will run this script and it will succeed because of that dependency analysis, right? For those of you who've done ALM for databases and data warehouses, you know that you have to be careful that you don't generate a script that you give to a DBA that then errors when they run it on production, right? So this dependency analysis is very valuable. Okay, but instead of running a script, I'm going to go ahead and just update the target. We can now refresh. And now everything like the Azure Blob data source is now in the source and the target with the same definition. Make sense? We'll now open up this model again. And then find that weather table in it. Switch to diagram view. And it's normally over to the right. There it is. So we'll drag this over here. So we've got this weather table in the model. And the kind of data architecture traditionalists may be asking, would we not put this weather data through the data warehouse? And absolutely we could. It would then be reusable for other applications other than just analysis services, right? And even if we did that, we would still want to do this process to harvest all of the measures and avoid reinventing the wheel, right? But in this particular case, I'm saying that, this weather data is coming from an Azure Blob data source. It's not a corporate sanctioned system of record. I'm going to make an exception, and I think it's okay to occasionally add some extra data from other sources. The reality is that in the real world, we do end up adding some data from other sources to our BI models, not just the data from the data warehouse. Okay, so I could, however, rename some columns and make it align with my corporate naming standards, etc. All right. First thing we want to do is create some relationships to other tables. So the obvious one is the date table. So let's go ahead and say create relationship to the date table based off date ID. Whoops, that's the wrong one. There we go, date ID, everything looks good. Okay, so we've got that relationship. Now, since this is geographical data, and this is all of the weather readings in New York for each zip code, right, for each day. This is geographical data, which we want to relate to the geography dimension, this pickup geography dimension. Now, this will be a common problem in this scenario where this geography dimension is coming from the data warehouse, and this data warehouse uses Kimball design best practices, and it has a surrogate key as the primary key of the table. We need to, in order to relate to that table, we need the primary key, the surrogate key as a foreign key in the weather table to create the relationship. Make sense? Now, the surrogate key will not exist in the weather data set from the Azure Blob data source because it's not coming from the data warehouse, right? So surrogate keys are generated as part of the ETL or ELT process, not just for better joining in the data warehouse, but also for data quality reasons where we don't have to depend on the quality of business keys in the source systems, especially when integrating data across different source systems. So we do not have the geography ID here in the weather table. So we want to perform a lookup to get that geography ID surrogate key, right? In previous compatibility levels, before the 1400 compatibility level, that was basically impossible. We'd have to do it at the relational level, and we'd have to end up putting this in the data warehouse, probably. But since this is 1400, I can use Power Query. So I can come in to the partitions for the weather table. And I'm going to go to Design. So this is opening up the M/Power Query query editor. I need to enter some credentials quickly. Here we go. So these are the credentials to the data warehouse, and I also want to go to the weather table, and I need to enter the key for the Azure Blob data source. Okay. So this is a sample of the weather data, and we basically want to create a new column on here called geography ID, which is the surrogate key from the geography dimension table. So in order to perform this lookup, we will say combine merge queries. This is very easy to do with Power Query. It's basically the same user interface that you get in Power BI Desktop. And we'll perform the lookup based on the zip code to the geography expression, also on the zip code. It will now prompt us for the privacy level, which I'm going to select organizational. So the privacy level, in case you're not aware, works the same way as privacy levels in Power BI, and you can look up privacy levels in Power BI. There's lots of documentation on it. And what this does is it affects what can be what we call folded to the data source. So Power Query likes to submit logic in the queries to the data source because it's more efficient. For example, if you have a filter, it can submit a where clause in the SQL query, and it's only going to return a subset of the rows, which is more efficient, right? So it likes to push as much logic down to the data source as possible, and we call this query folding. Now, in some cases, we may not want to perform that query folding if, for example, there's sensitive data that could be included in that where clause filter, like social security number, for example. Okay? But in this case, the data sources are organizational, so I'm okay. It'll just validate the join here. And I'll just let it finish here. There we go. So now we have this column, and I'm going to specify that all we need is the geography ID. And we should now have a column with the surrogate key. And this was actually looked up from the data warehouse, right? So when we refresh this table, it will submit a query to the data warehouse to perform that lookup to get the surrogate key. Make sense? And so here it will update the M expression to include that lookup. There it is. Okay, I'll just save this. And so if I scroll down, we now have a geography ID column that we didn't have before. And I can now drag this up to here and create the relationship to the geography dimension table. So in case you're not aware, these relationships here in the tabular model are more than just for referential integrity. These define the aggregation paths. This is what enables clicky, clicky, draggy, droppy data analysis, where people just drag objects onto visuals, and it can submit a query to Azure Analysis Services and not have to worry about performing joins because the aggregation paths are predefined. That's what these relationships do in a summary of what they do. Okay, so we're basically ready to deploy this model, and we're going to deploy it to the big server with 10 billion rows, right? So this now comes on to deployment methodologies, right, for analysis services. So there are basically two camps of deployment methodology, or schools of thought for deployment methodology. You've got the traditionalist camp, certainly with multidimensional. I'm assuming everyone knows that there's two modes of analysis services, multidimensional and tabular. Certainly with multidimensional, it makes sense to do all or nothing deployment, which is the traditional way to do it, where you package up everything and you, as one atomic unit, and you deploy it to your test environment, to your user acceptance test environment, staging, and then to production. And you perform a bunch of tests along the way, right? Now, the downside of all or nothing deployment is that you cannot deploy, for example, new bug fixes quickly because it's a bigger operation. So what people tend to do is they'll create a production branch for the bug fixes, and then they'll get the bug fixes to production quickly. However, if you create a branch, you're then in the realm of branch management, right? And because otherwise, you need to merge those bug fixes into the main branch. Otherwise, you'll be doing it twice in two different places manually. So there's only one way to do a merge with tabular models, and that's with BISM Normalizer. So BISM Normalizer can definitely help you in terms of your deployment strategy, especially in the branch management and branch merging area, all right? Now, there's also another school of thought, which is for tabular models, it's actually okay to perform an incremental metadata deployment, where I only pick and choose the objects that I want to deploy, right? And that's what I'm going to do here. And I've actually got I've created this BSMN file ahead of time. And this BSMN file is a BISM Normalizer comparison. I'll just quickly run it. And you'll notice that the source and target are pre-selected. The options are pre-selected. Even the skip actions are pre-selected, right? And all of that information is stored in this file, right? So for example, if I scroll down here, you can see that this trip table is already skipped because that skip action was saved in the file. So if you think about what this means, is that I can have a different one of these files for each of my environments, right? When I'm deploying these models, there's often things that I don't want to touch in the target. For example, roles. Roles is an easy one, right? My role membership on my production model could be completely different to my development and test role membership for the same role, right? Or, sorry, go ahead, sir. Yeah. Yes, absolutely. TFS and Git and other source control repositories can absolutely play into this. So these files can be integrated into source control, right? And these BISM Normalizer comparisons can also be run from the command line, which can then be integrated with automated build and deployment. So if you run this from a command line, the only parameter is the BSMN file because it has all the information in it, right? Okay. I can use these files kind of like configurations for each environment, right? So I don't want to touch my roles. I don't want to touch my data sources because my data source is pointing at a different instance of the data warehouse for development, test, and production. Another really common one is partitions, right? So the reason this trip table is skipped is because the version of the tabular modeler in source control is not partitioned. This is running locally here in Visual Studio, right? I don't have 400 gigabytes of memory on this machine, unfortunately, right? So if we look at the definition of the trip table, you can see that the version in source control, and in fact, the version of this trip table that we were looking at here in Visual Studio only had 1,000 rows because there is a select top 1,000 on it, and there's only a single partition. However, the server we're going to deploy to is the big one with 10 billion rows, right? So that thing has 120 partitions, right? And guess what? We don't want to mess with those partitions because if we deploy that same table metadata, those partitions are toast, and all of those 10 billion rows will just disappear. We'll end up with 1,000. So not quite all of them. But we don't want that to happen, right? So we need a deployment method that allows us to retain partitions, retain role definitions, data source definitions, and potentially other things as well. And there are a bunch of options with regard to that type of thing in here as well, which you can save in these settings in the BSMN file as well. OK, so let's go ahead and say hide skip objects so that we can focus on what we're actually going to deploy. OK, so we can see that we're going to deploy the Azure Blob data source, the weather M expressions. We're not going to touch the trip table because we don't want to lose the partitions. And all of these measures, for whatever reason, we're not going to deploy them. We're not ready. We haven't finished. This is the difference between all or nothing deployment and incremental metadata deployment for tabular models. We don't have to deploy, for example, the measures that we're still working on, right? Given the dependency analysis and for a tabular model, they're pretty well structured. It's pretty safe to do that, in my opinion. So we'll go ahead and skip those. And what else have we got? There we've got the weather table, the relationships we created, and the measures there. We'll go ahead and validate selection. And we got no warnings, so we'll go ahead and update. As you saw, we could have created a script to hand to a DBA, but in this case, I'll just go ahead and update the target. And we have to specify the privacy level again, which is what I discussed earlier about query folding. And again. And so it's actually deploying that weather table. It's already deployed the weather table to the model. And it's now refreshing that weather table. It knows that that's the only table that it needs to refresh. And it's actually performing the lookup to the SQL Data Warehouse right now. So if we were running Profiler on the SQL Data Warehouse, we'll be able to see that. And it's refreshed. And if we refresh this again, we should see that everything that we deployed is now both in the source and target, and what we skipped is not. And there it is. OK. So back to the Power BI desktop report that's connected to that same model in live mode, right? So here you can see there is no weather table. And if I'm going to come over here to this visual. So this visual is giving me the count of trips by each of the months in 2010. And I'm now going to refresh this, and we should see the weather table pop up over here. And there it is. And we can now drag the average precipitation in inches onto the visual. And now we get the aggregated value for precipitation in inches in New York across all of the zip codes aggregated to the months in 2010. And we can now start performing some analysis to figure out whether there is correlation between weather patterns and taxi movements. OK? Because these medallions go for $1 million on eBay to operate taxis in New York. So if I paid $1 million, I would want to analyze these trends and figure out how to optimize my business, right? Okay, so any questions about the demo? No? Okay. To summarize what we saw fine-grained partition management through the Tablet Object Model API, and we were executing that from Azure Functions to maintain that end-to-end platform as a service architecture. We saw BI schema compare for application lifecycle management, or ALM, and I'm not aware of any other vendor that has schema compare for BI models, for corporate BI. We saw Power Query data integration across different data sources, right? So we performed that lookup on the zip code to get the surrogate key. And we discussed deployment across environments and the deployment methodologies of how you're going to get these models to production in a reliable and repeatable way, an automated way. Okay? And some further info. This is a link to a white paper on BISM normalizer and application lifecycle management for tabular models. This is a link to the processing white paper with the code sample. Got a couple of blog links and a couple of white paper links with regard to bimodal BI, where we have the business and IT work in harmony so that we as IT professionals can harvest these insights from the analysts more easily. And that's my Twitter account. I'd love to hear from you. And feel free to fill in the evaluation. Feel free to tell me if this format worked, where I summarize the demos after, or whatever you want to let me know about. So thank you very much. We'll open it up for questions in a moment. So thank you all for coming. I hope you have an awesome rest of your conference. Thank you very much.